Hi guys, it's Kumar and today we'll be talking about the geometrical question that I shared with you in the last video. So let's look at this question. We are given that we have a rectangle A, B, C, D and the area is equal to 1008 square centimeter. So I have area of A, B, C, D equal to 1008. Now E is a point on AB and F is a point on AD, so that AE is equal to 3BE. So I know that the ratio that we are having, basically AE is to BE, is equal to 3 is to 1. It means that if my BE, if I assume it is X, my AE is nothing but 3X. Alright. Similarly, I have DF is equal to 2FA. This means that the ratio DF is to FA is equal to 2 is to 1, and therefore if I assume DF to be my Y, or rather let's take AF as Y, and therefore DF will become 2Y. Now you understand, if I do that, I am getting AB is equal to X plus 3X, which is 4X, and AD is equal to Y plus 2Y, which is equal to 3Y. Now I also know that area of ABCD is basically the multiplication of the breadth and the length, which means I could just multiply 4x and 3y and get the area, which is equal to 1008. Alright. If I go ahead solving this equation, is 12xy is equal to 1008, and therefore xy is equal to 1008 divided by 12. Okay, if you divide it properly, you should get something like 96 84. All right. Okay, now what you can understand is that we do not have individual values of x and y, but we don't actually need them to find the area of some of these figures. Okay, just knowing the value of xy is enough to find the area of lot of the figures in this diagram. For example, suppose I want to look at the area of triangle FCD. All right, FCD. Now I can say that area is nothing but half into DF into let's say DC. Now DF I know is 2y and DC is equal to AB, which is equal to 4x, right? So this whole area comes out to be equal to 4xy, and if I put the value of xy that I had got before, which is 84, I get this area as 336. Alright. Now one thing I want you to note is 336 is nothing but 1008 divided by 3. So what basically CF is doing is it's dividing this whole rectangle into two parts. This whole area is basically one third of the total area. So basically FCD is one third of the total area, and the quadrilateral ABCF is two-third of the total area of the rectangle ABCD. Now I want you to notice something. Suppose if I draw a perpendicular line at F, alright, and let's say this gets intersected at Z and Y. Now what you can see that FYCD is a rectangle, right? So I have YF equal to CD and YC equal to FD. So it is basically a rectangle. And what happens in a rectangle is the two triangles that are formed when you make the diagonal, they have the same area. Okay, so basically if I'm looking for my area of triangle FYC, it will be equal to the area of triangle FCD, and that will be equal to 336 again. Now obviously I'm not writing the units, but you should understand that all of them are basically square centimeters. Alright. Now what another thing we have found out is that basically YZ, or rather YF, okay, capital YF is doing the same work as uh, CF. Okay, we discussed that CF is basically dividing this whole rectangle into two parts, with one area being 1/3 and the other area being 2/3. Similarly, what YF is doing is it is creating one rectangle, is basically creating two rectangles, and the area of one rectangle is basically 1/3 of the original rectangle, and the other rectangle is basically 2/3. So what we are getting is, let's say, area of rectangle ABYF, if we want to see. Now see, this is nothing but y into 4x, right? Basically what I'm doing is I'm taking AF multiplied with AB. And this comes out to be 4xy, which is basically 336. So what I want you to understand is this is a very important line. The YF we have drawn is a very important construction, and this will actually help us to solve this whole question. Okay. The next thing I want you to do is I want you to focus on this triangle AE, AED, okay, and FZD. Okay. What we are going to discuss right now is the concept of similar triangles and how to apply that. Okay. So right now we are at this triangle. So I told you about triangle AED and triangle FZD. Alright. Now what I can do is I can prove that these two triangles are basically similar. Alright. How will I do that? I just need to prove that their two angles are equal, right? If I prove that any two angles for these two triangles are equal, I have basically proved that these two triangles are similar. Let me start with uh, angle EAD, which is equal to angle ZFD, which are both 90 degrees. Okay. Also, I have angle EDA, which is equal to angle ZDF, basically because it is common. Okay. Now, what I've done is I've proved that two angles are common. So I can say that triangle AED is basically similar to triangle FZD. Now what this does is it allows me to use a basic property of similar triangles, which is that the ratio of corresponding sides of two similar triangles are equal. In practice that looks like something like this. So if I compare, I will get, let's say, AD, and I take the ratio with FD. Okay, so I'm going from A to D and I'm going from F to D. So basically I'm taking the sides opposite to these two angles, and this is equal to AE by ZF. Okay, so basically what I'm taking uh, the sides opposite to this angle, which is common to both. Now notice something. I know that AE is equal to 3x from the previous diagram. I know that AF is equal to y. Sorry, I know that, yeah. I know that AD is equal to y plus 2y, which is 3y. And I also know that FD is equal to 2y. So I can put these values. I'll get 3y by 2y. AE is nothing but 3 2x. So what I'll get from this is ZF is nothing but 3x into 2y by 3y. Y gets cancelled out, 3 gets cancelled out, so we get ZF is equal to 2x. Okay, now why this is important we'll see in the next set, in another set of similar triangles that are present in this diagram, and we'll use this value to find something that is very relevant for this question. Okay, so if you look at this diagram, let me write down all the values that I've got. So I've got, this is x, this is 3x, this is y, this is 2y, this is again 4x, this is 3y, and this I've just found out to be 2x. Okay, now the reason I found out this is because, see, I've already found out that the area of triangle FCD, that is known to me. Okay, and I want to find the triangle DOF, right? The area of triangle DOF. Now, area of triangle DOF is nothing but the area of triangle FCD minus area of triangle DOC, right? This I already know, this is 336, and this is what I want to find out. Okay, I know that the base is 4x, and I want to find out what is the height. Okay, now to find this height, I need to use something, another principle of similar triangles that we'll use in a moment. But first I'm going to look at triangle FOZ and triangle COD. Okay, so basically this small triangle and this big triangle. Okay, what we already know is that basically FZ is parallel to CD. Okay, so if we use a formula for alternate angles, we are getting that angle OFZ is equal to angle OCD, and angle OZF is equal to angle ODC, both using the fact that okay, FZ is parallel to DC, which means the alternate angles are equal. Okay, so what we have basically proved that triangle FOZ is similar to triangle COD. And this is very important to us, and I'll tell you why. For similar triangles, the ratio of the corresponding sides is equal to the ratio of altitudes, angle bisectors, and the medians. It is basically this altitude that we are interested in. And let me show you how. Okay, see, we had this is equal to 2x and this is equal to 4x. I don't know the altitude. This O, let me call it P, and let this call it Q. This OP is what I'm interested to find out. Okay, now we'll use the property that we covered in the last slide. That was basically that the ratio of the altitude is going to be equal to the ratio of the sides, corresponding sides. This means that OQ over OP is nothing but FZ over CD. Alright, now we already know this is 2x by 4x, which is equal to 1 by 2. Okay, so OQ is nothing but half times OP. This is one thing. Another thing that you can notice is OQ plus OP is equal to df, which is nothing but 2y. If I put the value of OQ as half OP, I get half OP plus OP is equal to 2y. I get 3 by 2 OP is equal to 2y, which means I get my OP, which is OP as 4 by 3y. Alright. Now this makes everything simple for us. Now what I want to find out is what is the area of triangle DOC. Now this is nothing but half into 4y by 3 into 4x. Okay. So basically what we'll have is we'll have 8 by 3 xy. Alright. Now we know that xy is nothing but 84, and if we cancel out we are getting this is 28. So if I multiply 8 with 28, I'm going to get something like 224. Okay. Now this area is 224. This whole area we know was 336. Now what is left is just subtraction. So let's complete the formalities. Triangle, area of triangle DOF is equal to area of triangle FCD minus area of triangle DOC or COD, whichever you find okay, you can write. This we had found out in very starting. This was 336, and this is what we found out recently. This is 224, which means the final answer that we are looking for comes out to be 112. Okay, so the one takeaway that I want you to take away from this question is that sometimes when you start with two variables, for example, we started with x and y, it is not always necessary to find the values of x and y individually. See, the whole question worked that you arrange things such that you keep getting forms of xy because this is a value you already know. Okay, so this is the plan that you have to start with, and you have to control from that urge of finding x and y individually and then try to get the answer. If any of you have tried x and y, please share with us in the comments what did you get and whether you think it was the right method. So next time we'll discuss application of modulus, and please go through this question, try it out, and get back to us in the next video. We'll talk about how to solve this question. Thank you.